Well, I'm Abigail,
Hi, I'm Haley.
and we did our research project on the topic of quantum computing and improving the field of machine learning using quantum computers. So this first part of the paper is just the background information, and this first paragraph just talks about how machine learning is just a subset of artificial intelligence, and it goes through and talks about the different categories that are within machine learning. And then the second paragraph just goes through, talks about quantum computing and all the fun things in there and how quantum mechanics really influences the way computing works with qubits, entanglement, and superposition. And then in this section, the problem to be solved just talks about how, basically the topic of the paper, how quantum computing can help solve any thing that machine learning is lacking.
So we did some research on previous research that's been done in this field, and the earliest research on quantum machines and quantum machine learning is from around 2009. We focused mainly on the last 5 years of research, and the phrase quantum machine learning popped up a lot more and focused on using quantum data and information versus classical algorithms using quantum algorithms. So the algorithms and applications in quantum machine learning are split into 4 categories: search algorithms, quantum Fourier transforms, simulation of quantum mechanisms, and balance point algorithms. We focused on the Grover's search algorithm and QFT as the main points of this research paper. So the Grover's algorithm is used for searching unsorted databases, but can also be used for image classification and a wide array of applications. QFTs are used in all sorts of algorithms as well, including in Grover's search algorithm and Shor's search algorithm. We thought it was important to highlight the value of QFTs as they do help with processing and calculations on the quantum level. The implementation for Grover's algorithm consists of several different parts. So the initial step is a series of transformations. And it's broken down into calling a quantum oracle, which is a black box operation, taking in linear input and iterating through to check to see if it is at the goal configuration. And if it is, then the phase will shift by pi radians. The second part of this iteration is a diffusion transformation, and the iteration will take the modified state and amplify it. So we have some mathematical diagrams. And the second part that we focused on were QFTs and the circuits and the gates in QFTs and their applications in quantum algorithms.
So in this section, the advantages and drawbacks. So the advantages in using quantum computing in machine learning is basically the being able to use all, or I guess have all numbers between, if you have 8 qubits, you'd have all numbers between 0 and 255, whereas in classical computing, you'd only be able to have a certain set of numbers, like you'd only have one and not all of them. So it basically gives you a lot more leeway, a lot more of an advantage in being able to store data. And then the time it takes to do those computations. Um, but there are a lot of drawbacks just because it's new, it's expensive, and then I guess the quantum state is very hard to manage because it's very, very fragile. They say even sound can throw off the quantum state. And if you have a qubit that's not already fully processed and something happens and it throws off the quantum state, then you get a lot of errors as well. So yeah, that's for that section.
So in conclusion, we talked about Grover's algorithm and QFTs and the efficiency compared to their classical counterparts, and the advantages and drawbacks of quantum machine learning. And while we found that most of the algorithms are more efficient and their time complexities are better than their classical counterparts, it is still hard to do this on a non-theoretical level due to the costly hardware and what Abigail had mentioned before.
Yeah.
Thank you.